Welcome back to the workshop for one last video on the second section of the appendix, logical equivalence. So we have one idea left, logical equivalence. So now that we've spent a bit of time looking at truth tables, seeing tautologies, contradictions, what we want to say is that two compound statements are logically equivalent if they have the same truth values for each combination of truth values of the component statements. So that's a bit of a mouthful there, but what I'm trying to say is that if we were to construct a truth table which has both compound statements in it, then the values in each row would be the same. Okay, so that's what we want to take a look at here. So let's consider our notes. So again, this definition is exactly what we said. So we want to consider three situations. We're going to consider a conditional statement and the three variations of it. Its converse, its inverse, and its contrapositive. And we want to decide which of these is the variation equivalent to the original conditional statement. So for the conditional statement, we're going to consider P implies Q in each case. And then we have for the converse, it would be Q implies P. For the inverse, we are looking at not P implies not Q. And then for the contrapositive, we are looking at not Q implies not P. Okay. So we want to see if this is equivalent to P implies Q, or this, or this. Okay. Again, it's two statements, two component statements, P and Q. And then we want to construct the truth values for these two things. P implies Q and Q implies P to see if they are the same. So true, true, false, false, true, false, true, false. P implies Q, true, true, we're good to go there. True, false, that's no bueno. And then anytime the premise is false, the conditional is true. All right, now working the other direction. True, true, we're good to go. Anytime the premise is false, the implication is true. True, false, right? The premise is true, the conclusion is false, the implication is false. Anytime the premise is false, the overall conditional is true. So are these the same? Well, what we want to do is we just want to identify, maybe it'd be good to identify where they're not the same, right? They're the same in the first row and they're the same in the last row, but they're not the same here. False, true, true, false. So because of these two places, they're not the same values. So they are not logically equivalent. All right, so not logically equivalent. All right, so let's move on to our next one. Let's check that. Again, we're looking at not P implies not Q, the inverse of P implies Q. And we have component statements, P and Q. We're going to have to find not P and not Q. And then, of course, we want to compare P implies Q with not P implies not Q. So a bit to consider there again. So true, true, false, false, and true, false, true, false for our component values. We want to find the negation of P, which would be false, false, true, true. And the negation of Q, which would be false, true, false, true. So P implies Q would be true, false. Anytime the premise is false, the implication is true. And then not P implies not Q. Anytime the premise is false, the implication is true. True, false gives us false. True, true would be true. So again, we actually end up with these two middle rows not matching. So since they don't match, so not the same, not the same values, so not logically equivalent. All right, one more example. Will it be logically equivalent? Not sure. Let's find out. So the contrapositive is not Q implies not P. So we need to find essentially the same one, except for switch the order here. So the first 1, 2, 3, 4, 5 columns are going to be the same. So we've got P, Q, not P, not Q, P implies Q, and not Q implies not P. Excellent. So true, true, false, false, true, false, true, false. Not P would be negating or exchanging the truth values here. So false, false, true, true. Negating Q would be exchanging the values of this one. So false, true, false, true. And from there, P implies Q. All right, still the same thing, right? True, true gives us true. True, false gives us false. And anytime the premise is false, we get true for the implication. All right, so for not Q implies not P, the premise is false. So we get true. True, false is going to be false. Anytime the premise is false, we get true, and true, true gives us true. So in this case, everything matches. Right? True, false, true, true. So these two things are logically equivalent. A conditional statement and its converse are logically equivalent. Sorry, I think I said converse. It's contrapositive. A conditional statement and its contrapositive are logically equivalent. Conditional statement and its contrapositive are logically equivalent. Yay! And we'll actually use this idea as well when we are writing proofs in the next section. So contrapositive we'll want to be familiar with. The idea of a contradiction we'll want to be familiar with. And then, let's see, also the modus ponens would also be good to be familiar with. Of course, truth tables helpful as well. But that's all that I wanted to share for this video. So thank you for your time and attention for section 2 of the appendix. I'll see you guys back in the workshop a little bit later.